Okay, today we're going to be thinking about tangents and normals. So if we consider a curve, let's do something like this, and the tangent is going to be a line that's tangential to the curve. We'll just try and make it a bit close. There we go. There's a line that's tangential. This is our tangent, and it meets our curve here at point A, and that's x1, y1. Now, if we have a line coming down here, and that line is at right angles to our tangent, we call that the normal. And if we say that, and this here curve is y, the gradient dy by dx at point A is m, and the therefore the equation for the tangent is y minus y1 equal to m x minus x1. And you'll remember that from our general formula for a straight line. Now, you'll also remember from previously, when you get two lines that are perpendicular to each other, the gradients, when multiplied together, make minus 1. So the gradient of the normal must equal minus 1 over m. Therefore, the equation for the normal is y minus y1 equal to minus 1 over m x minus x1. This only makes sense if m does not equal 0. So let's look at a couple of examples. If we want to find the equation of the tangent and the normal to the curve y equals 2x squared plus 8 over x squared minus 9 at x equals 2. So we need to find the gradient. So we'll do dy by dx, and that's going to be equal to 4x minus, now this will become minus 2. Minus 2 times 8 is minus 16, and that'll be over x cubed. When x equals 2, we can get the y coordinate. Y equals 2 times 2 squared plus 8 over 2 squared minus 9, which equals 1, and dy by dx equals 4 times 2 minus 16 over 2 cubed and that will equal to minus, oh no, not minus 6, just 6. So the tangent passes through point 2, 1 with the gradient m equal to 6. So we know that y minus y1 equals m x minus x1. And so y minus 1 equals 6 x minus 2. So that's going to give us y equals 6x minus 11. And we know the normal passes through 2, 1 with m equal to minus a sixth. So y minus 1 equals minus a sixth x minus 2. And rearranging that, you're going to get x plus 6y equals 8. It's a good idea if you've got a fraction here to multiply through to get rid of the fraction. Let's look at another example. A curve has equation y equals 4 minus the root of x to the 3. The normal at the point at P 4, 8 and the normal at point Q 9, 1 intersect at point R. Find R. So we need to find, so we've got this curve, we need to find the equations for the normal at point P and the normal at point Q. So find R, so what the coordinates for. So the first thing to do is differentiate y. So dy by dx. Well, we're going to use the chain rule here. Let's just rewrite y here. So y equals u3, dy by du equals 3u squared, and u equals 4 minus x, and we'll say x to the half. So du by dx is going to be minus a half x minus a half, which will be minus 1 over 2 root x. And therefore dy by dx is going to be 3, 4 minus square root x cubed, oops, sorry, not cubed, squared, then minus a half 1 over root x. Now if you simplify all this and tidy it up a wee bit, you'll get 3, 4 minus root x squared over 2 square root of x, oh, and there's a minus, got that minus. There we go. So we want to find the gradient at point 4 and point 9. So when x equals 4, dy by dx is going to be minus 3, 4 minus root 4 squared over 2 root 4. So that's going to be minus 3. And when x equals 9, dy by dx will be 3 minus 3, 4 minus root 9 squared over 2 root 9, and that comes out at minus half. So for point P, for the normal, remember this is not a tangent, this is a normal. For the normal at P passes 4, 8 with the gradient. Now the gradient is going to be a third. And so the equation y minus 8 equals a third, x minus 4, which gives us y, 3y equal x plus 20. And going through the same process for the normal at Q, we'll get, I'm just going to write it down, but you do the same working. You would, Q's 9, 1, and the gradient for the normal at Q will be, that's meant to be, is it a half? It's terrible writing. Yes, it's meant to be a half. That will be 2. So the normal at point Q will be y equals 2x minus 17. Now I'm going to get a new sheet up. So we had the normal at P, and we had 3y equals x plus 20, and with the normal at Q as y equals 2x minus 17. So we're going to call this equation 1, and we're going to call this equation 2 because we wanted to find point R, and point R is where these two lines intersect. So we're going to, so that means so if we multiply this through by 3, so 3y equals 3, 2x minus 17, we can now equate these. So x plus 20 equals 3, 2x minus 17, and we solve for x and get x is 14.2, and then if we substitute that back in, we'll get y is 11.4. Therefore, point R is 14.2, 11.4. Now, find the area of the triangle PQR. So let's plot these points PQR. So we had point P as 4, 8. So that's point P. And my point Q as 9, 1. And point R is somewhere over here. Is that point R. So we've got this triangle. Now, if we draw a rectangle here, so this is 14 to 11.4. Q here is 9, 1, and P here is 4, 8. So we've got a rectangle, and we can work out the dimensions of this. So this line here, well, if the y coordinate is 11, 4, but the y coordinate here is 1, that must be 10.4. So that length of that side here is 10.4. And the length here, if this here is 14.2, but this x coordinate is 4, this must be 14.2, take away 4 is 10.2. So we can work out the area of that triangle, that rectangle. So the area of triangle PQR must equal the area of the rectangle minus the sum of the outside triangles. So this triangle, and this triangle. So now what's this length going to be? Well, if this is 14.2 and this is 9, so 14.2 minus 9 would give us 5.2. If this is 9 and this is 4, this length here must be 5. And for this one here, if this y coordinate is 8 and this is 1, this must be 7. If this y coordinate here is 11.4 and this y coordinate is 8, this must be 3.4, and we already know this length. So the area, I'm going to do this equals, the area of the triangle is 10.2 times 10.4 minus, so the first one is going to be a half, 5 times 7, plus a half times 5.2 times 10.4, add half, 10.2 times 3.4. Doing all that, you will get 44.2, and we'll just call it units squared, because we don't know the actual units. So I hope that helps.